I've always wondered what would happen if I ever got too close to a black hole. You know, those cosmic vacuum cleaners lurking in the shadows of galaxies, quietly swallowing everything that dares to wander too near? It sounds dramatic, and trust me, it is. But here's the twist. Black holes don't actually suck things in like cosmic vacuum cleaners. They're more like the universe's strict bouncers. Get too close, and you're not coming back out. When I first heard that even light can't escape a black hole, my brain did a little backflip. Light, the fastest thing in existence, just gone. Like a magician's disappearing act on a universal scale. That's when I knew. These things aren't just space oddities. They're literal physics nightmares dressed as celestial wonders. So how do these monsters even form? Picture a star, a massive one burning through its nuclear fuel, like a teenager burning through snacks during an all-nighter. Eventually, it runs out of energy, collapses under its own gravity, and boom, a supernova explosion. What's left behind? A dense, collapsed core that's so heavy, it warps space-time itself. That's our black hole. The key to a black hole's terrifying power lies in something called the event horizon, the point of no return. Cross it, and nothing, not even light, can escape. It's like the universe's version of a "do not enter" sign. Except if you cross this one, you're toast. Now, imagine you're floating in space, minding your own business. And there it is, a black hole. It doesn't look like a hole at all, but rather a perfect black sphere surrounded by swirling light and matter. It's eerily beautiful, like a celestial whirlpool made of pure darkness. The glowing disk you see around it is called the accretion disk, a storm of gas and debris spinning at nearly the speed of light, heating up and radiating energy, like a cosmic bonfire. You'd probably think, maybe I should get closer. And that, my friend, is how every bad sci-fi decision starts. Let's say you do approach it. As you drift closer, something strange happens. Time itself begins to slow down. To someone watching you from a distance, it looks like you're moving slower and slower, like a bad Wi-Fi connection. But from your perspective, everything feels normal. That's relativity, playing its weird little game. From their view, you'd freeze just above the event horizon, forever suspended in time. But from your view, you'd plunge right through. And here's where things get freaky. Once you cross that event horizon, there's no going back. Gravity becomes so extreme that it pulls more on your feet than your head. Scientists call this spaghettification, and yes, it's exactly what it sounds like. You get stretched thinner and thinner until you're basically cosmic pasta. Bon appétit. But let's pause the horror for a second. What's actually happening inside a black hole? The truth is, we have no idea. Every law of physics we know just breaks down. Gravity becomes infinite. Space-time curves into madness. And all our equations throw their hands up and walk out. At the center of it all lies the singularity, a point of infinite density, where everything that fell in gets crushed into nothingness. It's like trying to divide by zero. But with matter, some theories say that what goes into a black hole might not be lost forever. Maybe, just maybe, it gets stored on the event horizon, like a cosmic hard drive encoded in quantum bits. That's the idea behind the holographic principle, suggesting the universe itself might be a giant 3D projection of 2D information. Yeah, reality might literally be a hologram. Good luck sleeping after that. Now, you might be wondering, could we ever use a black hole for something? Surprisingly, yes. They're not just destroyers, they could be power sources. The energy from the spinning accretion disk around a black hole could theoretically power entire civilizations. Some scientists think advanced alien species, if they exist, might already be doing it. Imagine aliens mining energy from black holes. while we still struggle to charge our phones overnight. And what about wormholes? You've seen them in movies, black holes as cosmic gateways to other universes or distant parts of space. In theory, it's possible. Einstein's equations allow for wormholes, bridges through spacetime. But in practice, they'd collapse faster than my motivation on a Monday morning? Unless, of course, we find a way to hold them open with exotic matter, a substance that hasn't yet been proven to exist. Let's get back to our doomed journey. You're falling deeper now. Outside, the universe continues as usual. Stars shimmer, galaxies spin, and your friends back on Earth might still be scrolling through cat videos. But for you, everything changes. The light from the stars above gets bluer and brighter as it's pulled along with you. The universe seems to accelerate, collapsing into a single, brilliant point before your eyes. Then darkness. Some physicists think you might emerge somewhere else entirely, maybe another universe, maybe another time. Or maybe you just end. It's poetic. Really, the same universe that gave birth to stars, planets, and you also built something that can erase it all in a heartbeat. But black holes aren't just cosmic destroyers. They're storytellers. Every one of them carries the history of what it's consumed: stars, planets, light, time itself. In a way, they're like nature's ultimate archivists, keeping secrets we'll never fully decode. And the fact that we can even study them, that we can map their shadows and detect their gravitational whispers, means we've come pretty far as a species. Speaking of gravitational whispers, remember that famous event in 2015 when scientists detected gravitational waves for the first time? Those ripples in space-time came from two black holes colliding billions of years ago. The universe literally shook, and we felt it. That's not just science, that's cosmic poetry. So next time you look up at the night sky and feel small, remember, we're not just tiny observers, we're part of that grand cosmic story. The same physics that creates black holes also makes you possible. Space isn't just out there, it's part of us. Made of the same stardust, governed by the same laws, pulled by the same gravity. And who knows, maybe one day, when humanity finally explores beyond our solar system, we'll stand on the edge of a black hole, not with fear, but with awe, not as victims of its pull, but as witnesses to the universe's greatest mystery. Until then, stay curious, stay brave, and please don't go jumping into any black holes just to see what happens. We need you alive for the next episode. If you enjoyed this cosmic roller coaster, don't forget to like, share, and subscribe. The universe has a lot more secrets to spill, and trust me, you don't want to miss what's coming next.